planimetric maps and topographic maps. Planimetric maps, as their name shows, right? These are the natural and cultural features in the XY plane only or XY view only. Objects shown are called planimetric features. So you don't know if there is a tree, you would only know what is X and Y coordinate of that tree. You won't know how tall that tree is. If there is a ridge or mountain, you will only know the X and Y position of that mountain. You don't know how tall that is. So such kind of maps are called planimetric maps. Now, there is another type which is topographic maps. Topographic maps includes the planimeter features like X and Y and configuration of our surface. Also includes the Z direction. Like if there is a slope or if there is a height of that mountain, everything will be included in topographic maps, right? So what are the methods? How we build these maps, whether they are planimetric maps or whether they are topographic maps. What are different methods to, get the data which will help you guys to build those maps, whether those are planimetric maps and whether those are topographic. There are two basic methods. One is the aerial method, photogrammetric method, right? Photogrammetric method is like you use aerial photography, whether through drones or whether through helicopters or whether through any kind of technique, planes, or so you use this method where you put some camera or anything on on an object which is flying in the air. Okay, and from there you take pictures, you measure the coordinates, whatever you do, you gather that data and then you use that data in your computer softwares and to build the those topographic maps, or whether you want to build the planimetric maps. यार वो तलहा अकेला उसका मसला है ना, तो इसका मतलब है कि उसको कोई मसला है, इसमें मैं क्या कर सकता हूँ, बाकी को तो प्रॉब्लम नहीं है. So ground techniques you usually use, like you use theodolites, you use other equipment, survey equipments to, measure the lengths, measure the coordinates, to measure the angles. So you get all that data by ground methods, and then you use that data, refine that data, make calculations, and then you build those maps, whether you want to build that planimetric maps or whether you want to build the topographic maps, right? Now, one of the fundamental thing in maps is you cannot build the actual scale map, right? You have to design, you have to come up with some, map scale, right? So there are certain types of map scales, uh, which is equivalence scale, which we call, in which we define like, okay, 1 inch on that map is equal to 200 feet in a real scenario. Those are called equivalence maps. Then there are maps where you use the ratio, like each inch on this map will be, for example, equal to 2000 feet in the real scenario, right? Similarly, graphically, a bar scale or labeled grid lines spaced throughout the map at uniform distance. So you might see that you have those maps papers where there is already divisions given there in inches or in 10th of inches or in 20th of inches. They will help you to build the maps. You just decide the scale, and then according to that scale, you build the map on those sheets. Then there are map scale sizes. Large scales, in large scales, 1 inch is equal to 200 feet, right? And the ratio would be 1:2400 inch or feet or meter, whatever you want, right? 1 inch is equal to 200 feet mean. 1 inch is equal to 200 feet. If you make them inches, 200 feet would be 2400 inches. So 1 inch is equal to 2400 inches, and the ratio becomes 1:2400 or larger. So any scale which is in this range, where 1 inch is equal to 200 feet or larger, are called large scales. And then there are medium scales. In medium scale, 1 inch is equal to 200 feet to 1 inch is equal to 1000 feet, right? So that those are called medium scales maps. And the small scale are where 1 inch is equal to 1000 feet or smaller, right? So these are different scales of the maps. Now, once you start surveying, right, whether this is mapping survey, whether this is topographic survey, or whether this is planimetric survey, first, you establish the controls, right? Control is where you have the established points or established line or established station, from where you carry out using that feature or that point as a reference point, you carry out the map of the rest of the area what you want to map. Now, horizontal control for a mapping survey is provided by 2 or more points on the ground, permanently or semi-permanently monumented and precisely fixed in horizontal position by distance and direction or coordinates, right? So horizontal control is like you have minimum of 2 points. Why you need 2 points? So you can have a reference point. If you have only 1 point, then you don't have a checkpoint. So you should have at least 2 points whose direction and distance are known, right? From major control, whatever your main reference point is, right? Similarly, vertical control is provided by the benchmark in or near the track to be surveyed. Track means whatever area you want to survey. That is the benchmark for that area, vertical control, and becomes the foundation for correctly portraying relief on a topographic map. So this vertical control would be reference point for the area where you are surveying for the topographic map. That means this vertical control is related to the Z direction, like what would be the height of trees, what would be the height of, mountain, what would be the depth of rivers. So anything which is in Z direction would be through vertical control. So anything so far? Any questions so far? Do you understand what I'm saying?
Yes, sir.
All right.
Yes, sir.
So in this slide, you can see, yes? इसका ये है कि जो आपके पास वो क्या स्केल्स होते हैं, जो नॉर्मल स्केल्स होते हैं, क्या कहते हैं उसको, जिसकी मदद से आप डेविएंस करते हो, ये जो आपके अवेलेबल होते हैं शॉप्स पे, क्या नाम होता है उनका, जिनको हम रूलर कहते थे, हाँ, उन पे डेविएंस होती हैं, ठीक है ना? आपका जो भी सिलेक्शन है स्केल की, वो कुछ ऐसी होनी चाहिए जो उन डेविएंस से मिलती हो, वरना आपको गेस करना पड़ेगा कि, हाँ,